Kia ora koutou. These are some trig integrals done for Connor, but also probably for quite a few other people. And all they are is backwards chain rule, but I've done them without a U substitution. So I guess the clue that I'm giving you that you don't have when you see these in a problem is that I've just told you that there's nothing particularly difficult in here. There's no integration by parts or anything like that. You can do every single one of these with a U substitution, but by now, hopefully, you're not needing to. The secret to doing these is when you get to the end, always quickly differentiate it back to make sure that you've got it right. Okay, so before we start, let's just look at a couple of basic trig derivatives. If we've got f of x here and f dash of x here, whoops, don't know what just happened there. Let's try that again. We'll make that f dash of x, and here we've got f of x. Just going to change the pen. Okay, so here's my table. Sine of x differentiates to cos of x. Cos of x differentiates to negative sine of x. And tan of x has sec squared of x as its derivative. Now, I haven't used any other ones in this video, so that's all you've really got to know to get going. What I'd like you to do now is to pause the video and just have a look through the questions. So here are the first 1, 2, 3, 6 of them. Okay, so down to here. And then here are the last 4. So there's 10 questions altogether. So pause the video and have a go at doing all 10 of them, and hopefully you'll spot some patterns. And now I'm going to go through them. Okay, so when I look at cos of 3x minus 4 dx, I think to myself, well, it's a cosine function, and if I look at the inside function, the derivative of that is 3. Now 3 is just a scalar, right? It's just a constant, so this is not too bad. I'm going to have to do some adjustment, but not too much, because sitting here, I've got an invisible 1, right? So integrating, we'll leave a gap for our coefficient, and we're going to have sine of 3x minus 4, and I have to divide out the 3, okay? So let's go through how I did that even more slowly. Well, I look at this, and I see that the integral of cosine is sine. So I'm going to write down sine of that function 3x minus 4, because when I differentiate this, my inside function is 3. So I'm going to multiply by 3 to differentiate it. But I don't want 3 times cos of 3x minus 4, I just want 1. So that's why I'm going to divide out the 3. And we can check that just for this first one of differentiating this function here. So if I start with my answer, I'll get dy by dx is equal to 1/3 times 3 sine of 3x minus 4 plus c. Okay, now I'm not going to go that slowly on all of the other ones, but hopefully that will get everyone underway. The next one is one where it's directly off my formula sheet. So the integral of sec squared x is equal to tan of x. When I move to this one, the integral of sec squared 2x, all I have to do is watch out that I've got a backwards chain rule, right? So sec squared anti-differentiates to give me tan. So let's write this down. So tan of 2x. Now, plus c. When I differentiate this, I'm going to get sec squared of 2x, which I want, but I'm also going to have to multiply by the 2. I have to undo that multiplication by timesing by a half. And again, you can check this one by differentiating it. On to the next one. Well, I've got sec squared here, and then my inside function has got a derivative of 2. So this integral will be tan of 2x plus 1, but I have to divide out the 2. So we get a half of tan 2x plus 1 plus c. So in all of these ones here so far, the pattern that I've got is that I've got an inside function of x, but I've got a multiple of its derivative sitting here, right? So in this case, the derivative of 3x minus 4 is 3. So I ended up having as my answer 1/3 sine of 3x minus 4 plus c. Right, this one was the easy one. And here, the derivative of 2x is 2, so I end up with 1/2 here. And the same thing here, the derivative of 2x plus 1 is 2, so I end up having to multiply by 1/2. So that's the basic pattern that we're looking for. Now I've started to crank them up a little bit, but once you've really got that idea, and you have to do quite a bit of work to make it completely fluent, you can spot slight variations in that pattern. For example, in this one here, I've got 1/2 times sec squared of 2x plus 1 dx. So that's going to integrate to give me tan of 2x plus 1 plus c. When I differentiate this, I'm going to have 2 here. I need to undo that 2 by 1/2, but I also need to multiply by the 1/2 that's in the question. So this one will be 1/4 tan of 2x plus 1 plus c. Here's the next one. So the integral of sine will be negative cosine of x over 2 plus 3 plus c. When I differentiate this, I'm going to get times 1/2, and I don't want that. Right? So I have to multiply by 2. So it will be negative 2 cos of x plus 2 plus 3 plus c. And as usual, we can differentiate this using the chain rule and check that we get back to here. Now let's look at the next one, which looks much worse, but is fine. The pattern that I've got here is that I've got, you can think of it as u dash times sine of u dx. Right? Now that's not that proper a way to write it, but what I'm getting at is that here, the inside function is x squared, and sitting here I've got a close relative of the derivative, right? So the derivative of this thing here is 2x, and here I've got x. So in this case, my integral, I'll just erase that so you guys can see the question. There we go. My integral is going to be, let's see, well, we'll start with cos of x squared plus c. Now we need to make two adjustments. Cosine differentiates to negative sine, and we want positive sine, so we have to plonk in a negative. And the derivative of the inside function is 2x, and we just want x, so we multiply by 1/2. So that's my final answer there. Right, the next one has a similar pattern. We're going to start by saying, well, here, the derivative of 6x cubed is 18x squared. And I've got 3x squared. So I just need to make an adjustment to it, and we'll be fine. Right, so this one will be cos of 6x cubed plus c. I'm going to need a negative sign because I haven't got a negative here. And now instead of 18x squared, I want 3x squared, so it's times 1/6. And we've got two last ones where I've just chucked in some combination trig and exponentials. So for e to the 2x cos of e to the 2x dx, I'm going to start by saying, well, it'll be sine of e to the 2x plus c. And I don't need to do any adjustment there. The reason that that one is much easier than it looks is that here's my inside function, e to the 2x. Oh, I do need to do an adjustment, sorry, before someone tells me. I need to have a 1/2 here. Right, so e to the 2x differentiates to give me 2e to the 2x. But I don't want 2e to the 2x, I just want 1e to the 2x. And as usual, we can check this by differentiating it at the end and seeing that we get back to this. I think there's one left to go. Yeah, this one here. Okay, so no trig this time. But the pattern that I've got is x e to the 3x squared dx. So if I look at the e to the 3x squared, I know that we can try something like this. E to the power of 3x squared plus c. When I differentiate the inside function, I get 6x, and I just want 1x. So I have to times it by 1/6. Okay, because I want x and I get 6x. So that's that one there done. So kind of hopefully that helped, and anyone else watching. I'm going to do a second video in a moment on some slightly harder trig integrals, but hopefully that sets a few of you up well to go and do lots of practice on both differentiation and integration of simple trig things, expressions.